Welcome to In 5 Minutes. We take problem on bending stresses. Our problem statement is a simply supported beam of 8 meters span carries a UDL over the entire span. If the maximum permissible bending stress in tension is 30 meganewton per meter square and in compression is 45 meganewton per meter square, find the maximum UDL intensity the beam can carry and the corresponding maximum bending stresses in the beam. The cross section is as follows. Top flange is 100 mm into 30 mm. The web is 30 mm into 120 mm and bottom flange is 120 mm into 50 mm. So from the given information of the cross section of the beam, our given beam is a I section beam. So we first draw the figure of the section of the beam as well as the loading diagram of the beam. So this is a representative cross section of the given beam where your top flange, this part is 100 mm multiplied by 30 mm. The vertical part, which is called as web, is 30 mm multiplied by 120 mm, whereas the bottom flange of I section is 120 mm into 50 mm. And this is the corresponding loading diagram of the beam, which is a simply supported beam supported at point A and B and carrying a UDL of intensity W over the entire span, which is 8 meter or 8000 mm. We first note down the given data. The given data is maximum permissible tension is 30 meganewton per meter square, which is megapascal, so we can write in Newton per mm square as 30 Newton per mm square. Similarly, the maximum permissible compression is given as 45 meganewton per meter square, which is equal to 45 megapascal or 45 Newton per mm square. Next, in the problem we have to find out, we have been asked to find the maximum UDL intensity which the beam can carry, that is W. Second, they have also asked the corresponding maximum bending stress which is induced in the beam. So we have to determine for this value of maximum loading the maximum permissible bending stress. The given data in the problem is the maximum permissible stress in tension is 30 meganewton per meter square, which is nothing but megapascal. So if we convert into Newton per mm square, we get 30 Newton per mm square. Similarly, the maximum permissible compression is given as 45 meganewton per meter square, which is equal to 45 Newton per mm square. Next, in the problem, we have been asked to find first the maximum UDL intensity which the beam can carry, which is nothing but W. Then second, they have also asked to find out maximum bending stresses induced in the cross section due to this value of intensity of loading. So we need to find sigma C max as well as sigma T max developed on the extreme layers above and below the neutral axis respectively. So let's solve this problem.